Okay, so physics paper, year 10, mid-course examination, question 1. Here we go. It's about a bus and they've given you a distance time graph and they've asked for the letters of the sections where the bus is stationary. Okay, well, first of all, there's a bit of a clue there, isn't there? Because it says letters and sections, so we're looking for more than one of them. If we look at the graph, any time on a distance time graph that the line is horizontal, then that means that the object's stationary. And that happens in 3 sections of the graph: B, D and F. So that's our answer: B, D, F. For the next part of the question, it's asking us to calculate the speed of the bus during section C of the journey. So the first thing that we've got to do is we've got to take information off the graph. Okay, so you can see this is 5.0 minutes here and this is 7.0 minutes here. So that means that the change in time for during part C of the graph is 7.0 minus 5.0. That gets us 2 minutes. Okay, but if you look at the question, it's asking for it in meters per second, so we're going to have to convert the minutes into seconds. So 2 minutes is 120 seconds. Then bring it over to the y-axis. Okay, and be careful. Why? Because you can see that there's 10 small squares, okay, between there and there, or 5 small squares between 1.0 and 2.0. So that means that one's 8 small squares up, so that's at 1.8 kilometers. And similarly, that is 4.4 kilometers. So to work out the distance, we're going to do 4.4 minus 1.8, and that gets us 2.6. But again, that's in kilometers, so we're going to convert that into meters, which means that we need to multiply by 1,000, so that's 2,600 meters. Okay, so what have we done so far? We've taken information from the graph. Next thing, we look back at the question, it's asking us to calculate the speed. So step 1 is to write down what the question tells you. Step 2 is to write down what the question asks you. So the symbol that we're looking for is V. So that's the unknown. Third step in the 6 steps to calculation bliss is to write down the formula. So hopefully the formula is pretty much jumping off the page at you. If it's not, then you can check your formula sheet. Then we're going to do the substitution. So that's step 4. So it's 120 divided by 2,600. Whoops, the way round. 2,600 divided by 120. My bad. Okay, and then steps 5 and 6. That's going to be the answer, which is 21.666666, and then you keep going, and there's a 7 on the end if you look at your calculator screen, and the units, which are meters per second. Okay, but writing down all of that precision doesn't make sense. Why? Because you can see from the question, okay, that look, we know the time to 2 significant figures. We know the distance to 2 significant figures and 2 significant figures, which means that we should be giving our answer to 2 significant figures only. And if you take that and round it to 2 significant figures, that gets you 22 meters per second, which is the best answer. What does the graph show us about the speed of the bus in section E compared with the speed of the bus in section A? Well, it's a distance time graph, so hopefully you know that to find the speed, we're looking at the gradient. And here you can see that this has got a relatively high gradient compared to section E, which has got a relatively low gradient. So there's your answer right there. The speed in section A is higher than in section E. Why? Because the gradient is higher than in section E. Now, careful about the language that we're using here. If you're talking about the line, then you can say that the line in section A is steep, okay? But if we're talking about the gradient, gradients can't be steep. Gradients can be high, gradients can be low. Okay, so careful with the language that you use in there. Ideally, we're aiming for high gradient for section A. We've been asked to complete a velocity time graph in part B, and they've given us this information. Okay, so to get ourselves started, we want to work out the velocity, which is displacement over time, and I'm going to leave it in kilometers and minutes this time. Why am I doing that? Because I looked ahead and I can see that the graph is in kilometers per minute. So that means 7 divided by 14 is 0.5 kilometers per minute, just like that. Okay, so that whoops, that wasn't very good, was it? Okay, I want it at 0.5 on the y-axis. Okay, and because it's a constant velocity, I know that that's not going to change with time. Okay, some of you drew a displacement time graph here, RTFQ. Alright, it's a velocity time graph now. Okay, sorry my lines are not particularly horizontal. Okay, I'm sure that you drew yours with a ruler. That's the end of question 1.